In this video, we're going to talk about how we evaluate the derivative of a secant function. So the derivative of a secant function is secant x tan x, or another way of looking at it, a more intuitive way of looking at it, is the derivative of secant x is equal to secant x tan x times the derivative of x, or depending on what x is, it'll be the derivative of secant x, or secant whatever, is equal to secant blank, whatever this is, times tan blank, whatever this is, times the derivative of whatever is in this term here. So let's demonstrate this by doing an example. And in doing this example, I am assuming that you are already familiar with the power rule. If you aren't quite comfortable with the power rule, I've made a video on the power rule, and I will link the video here to this one. So let's say you're given the function g at x, and g at x is equal to secant root x. How do we evaluate this derivative? Well, in order to do so, we would write g prime at x is equal to, secant blank. And before I continue, I'm also going to make note that you can also write this as secant times x to the 1 over 2. Now that'll be particularly useful for evaluating this derivative. So to continue, the derivative of secant x to the 1 over 2 is equal to secant blank, whatever this term is, which is this term here. So we're going to write that here, x to the 1 over 2 times tan x to the 1 over 2 times the derivative of blank, this term here, times the derivative of x to the 1 over 2. And from our power rule, we know that the derivative of x to the 1 over 2 is 1 over 2 times x to the negative 1 over 2, because 1 over 2 minus 1 is negative 1 over 2. Of course, we can leave it there, but what I'm going to do is I'm going to simplify this even further. So I'm going to bring this out to the front here, and one thing to note is that if you ever see a negative in the exponent, it just means 1 over that. So we can write this as 1 over 2 times 1 over x to the 1 over 2 times secant x to the 1 over 2 tan x to the 1 over 2. And then we're going to simplify this even more. So as you can see here, this would be, these two are denominators. So what I'll write here instead is I'll go secant times x, we'll go root x, secant root x tan root x divided by 2 times root x. Alright, and there you have it. So let's do one more example here. And for this example, I am assuming that you are relatively comfortable with evaluating the derivative of a tan function. If you aren't comfortable with evaluating the derivative of a tan function, I've actually made a video about tan functions, derivative of a tan function. I'll link it to this video for you to reference for this next question. So let's say we get a function f at x, which is equal to secant of tan x. How would we evaluate this this derivative? Again, it's the same thing. We would just use this format here. So we'll go f prime at x is equal to secant blank, okay, which would be secant, what is this blank term here? Well, that will be this entire tan x term. So we'll write secant tan x times tan of tan x times the derivative of blank, so times the derivative of whatever's in here. And in this case, it will be times the derivative of tan x. Well, we know from our previous video that the derivative of tan x is equal to secant squared x. Okay, secant squared x. Okay. X. All right, secant squared x. And then, yeah, so there you have it. So that's the answer for this question. And in the next video, we're going to discuss how to evaluate the derivative of a cosecant function. Thanks for watching, and we'll see you in the next one.